Okay, let's pretend this is our score sheet and not a Google Sheet, and we need to transcribe these data under a Google Sheet. So we'll go over here and we'll create a new Google Sheet, right? And we have full and partial counts, and we have those for simulation 1, and we have them for simulation 2, and we also have 2 replicates of each simulation. So I'm going to make a third header row here with replication. Right? I'm going to copy that, and then we're going to merge simulation 1 across and center it. I'm going to merge that header across and center it. We're going to merge this header across and center it. And now we have a pretty replication 1. How about let's center those words as well. Make it super pretty. And let's create replication 2. So that's all the same, except for this is replication 2 and not replication 1. All right? So one of the things that several groups did was they just started their data right in row number 1 and didn't have any column headers for what those data are. One of the things you want to be sure to do is have column headers so that the future you can look back at this file and know what these data are. A second thing is some of the groups just computed the relative frequencies in their head or possibly using a calculator and didn't start with the raw data. And you always want to start with the raw data because you want to have a paper trail of any manipulation of raw data that you have. So we're just going to paste in that raw data. I'm not going to type it in like you did, but we're just going to paste it in. Right? Didn't want to paste in. Let's try that again. All right, let's title the spreadsheet Bio 107 Stickleback Evolution Simulation. There we go. All right, we now need to make a chart of how the relative frequency of the partial morph changes over time. So we can make that easy by having the columns that we want to plot together. So I'm going to create my plot data down in this region right here for simulation 1. And there's 3 columns of data that I want. I want the generation, I want replication 1, and we'll just call it rep 1, and rep 2. All right? And let's put some numbers for the generation. And we need to make relative frequency. And we want a formula here that takes the raw data and turns that into a percent data. So the raw count and turns it into a percent data. We don't want to do this in a calculator because then we won't have a paper trail of the actual calculations we made. We don't want to do it in our head because we won't have a paper trail of the calculations that we made. And it could be that our brain didn't calculate it correctly. So here we go. I'm going to the relative frequency of the partial morph is going to be its count divided by the sum of the full and partial for that generation. So there's the sum. That's in the denominator. Right? And we want to multiply that by 100 to turn it into a percent. And there's the formula. And we want a formula like that for each one of these counts. And we do that just by filling down. All right? And that gives us the relative frequency, or the percent, for each one of those counts. We also get 2 junk values because we don't actually have any data for those generations. So let's delete those, right? Now we need to do that for rep 2. So I'm just going to do the same thing. Here's replication 2, simulation 1. That value divided by that plus that times 100. And fill that down, and we've got some junk data. We don't want that. Now we have a nice clean data set for plotting. And we can do that by just highlighting those data, going to insert chart, and there's our chart. If it gave you a different chart time to start off with, that's pretty easy to fix. You can just edit chart, and you can choose the chart type right there, right? So we want to clean this up a little bit. We need a better title. We need a title for the y-axis. Go over to customize, chart title, right here. This is simulation 1, and we can even name it. It's simulating natural selection. All right. We want to give the y-axis a title. That's the vertical axis, and that is relative frequency partial morph. All right? Or we can actually just put frequency of the partial morph, percent as our unit. And we have a pretty good looking plot right there. So pretty quickly we can do that for number 2. All right? We want to just copy those over. 1, 2, 3, 4, 5. Rep 1 is going to be that divided by the sum. Oops, except we want simulation 2 equals that divided by sum of that plus that. And we want to fill that down. It only goes down 3 generations. Same thing for rep 2 equals simulation 2, that divided by that plus that. And that one only lasted 2 generations. And now we want to quickly plot it. Insert chart. That gives us our plot. Let's clean it up. Vertical axis title, frequency partial morph, percent, and chart title, simulation 2, and that is simulating something called genetic drift or just drift. And here's our 2 charts. Let's just line those up, make them look nice. And there we go. We've got the change in frequency of the partial morph over time under 2 models of selection that we've simulated. 2 models of evolution that we simulated. The first model, we modeled natural selection, where there was an advantage. One of the traits had a higher probability of reproducing than a second trait. The second simulated genetic drift, in which both phenotypes had equal probability of reproducing.